video, peeps, we're going to be talking about what determines the difference between exponential growth and exponential decay. So we're going to be looking at the difference in those functions, not really graphing things out formally. We did that in a previous video, right, where you looked at earlier, where we looked at how to graph things out. And that was in section 8.7 in Algebra 1, where we rocked graphing out exponential functions. So this is going to be more like, how can you tell if a graph is growth or decay before even graphing it? So let's take a look at that. Well, we know the general form is y equals a times b to the x. And if you didn't know that, well, now you know. That is an exponential function, where a is your starting amount, y is the total amount that you're getting at any time x, the input, and b, that is either your growth or decay factor. So the question is, when is it growth and when is it decay? It's very simple to understand when it's growth. It's going to be growth, it being this function, when b is greater than 1. Because if b is greater than 1, take like y equals, let's say, 3 times 2 to the x, for instance. Right? Or just even y equals 2 to the x. Here's a case where b, the value being raised to the power, is more than 1. What does that mean? Let's take a look at what happens when we plug in numbers here, and we'll be able to see why when b is more than 1, that we have an exponential growth function. Well, let's plug in x equals, I don't know, negative 1. We'll plug in a negative value. So we're going to do 2 to the x. So that's 2 to the negative 1 is 1/2. Then we'll plug in 0. That's 2 to the 0 is 1. And then we have 2 to the 1. Well, that's just, let's think about that, 2. And then we have 2 that we're plugging in. That means multiply 2 by itself twice. And then 3, that means multiply 2 by itself 3 times, and that's 8. And we could keep going on and on and on. But what you see here is, as x gets bigger, y gets bigger. Why is that? Because as x is getting bigger, that is telling us to repeatedly multiply, in this case, by a value that is more than 1. And if I'm multiplying a number that is more than 1 by itself more and more times, I am going to get larger and larger positive values. So that causes a graph to look like this. So negative 1, 1/2, if we just kind of graph it out real quickly, 0, 1, 1, 2, I'm just graphing out the points from this table, 2, 4, and then you get 3, 8. So you get all these points here, and you get that beautiful yet terribly drawn exponential function, right? If only I could have gone through those points. Whoa. Okay, so the point being is, though, you get that awesome exponential function that has that real steep increase, because the higher that x gets, the more that we're multiplying by 2. So the moral of the story here, peeps, as x gets bigger, y gets bigger, if and only if b, this factor right here, is greater than 1. So let's look at when we have decay. All right, so exponential decay. Well, that's going to happen, again, the general form, a times b to the x. And let's look at something like, I don't know. Let's look at something simple, like y equals 2 times 1/4 to the x. Here you have that a is 2, that's your starting amount, but the amount that you're repeatedly multiplying by is 1/4. So this actually speaks to the idea that in order to have decay, have a graph that goes down like that, you need to have a b value, first of all, that is greater than 0. If it's less than 0, we'd have values that would alternate between being positive and negative. So we have to be greater than 0, this value right here. But it also needs to be less than 1. If we're less than 1, think of it this way. Pretend that you have, I don't know, like a piece of paper, right? And if we take 1/4 of that piece of paper, that's this much right here, roughly. That's 1 time that we've multiplied by 1/4. If we take 1/4 of that, now we have this much paper right in here, and 1/4 of that, now we have this much paper in there, and then 1/4 of that. And you see how quickly we have very little amount of that paper left, because you're repeatedly taking 1/4 of what we started with. And when you multiply by a number less than 1, that is positive, yet greater than 0, we will get values that are smaller and smaller. Now let's see that numerically. So let's plug in, I don't know, x equals negative 1. 1/4 to the negative 1 is like doing 2 times 4, because the 1/4 flips. 2 times 4 is 8. Then we'll plug in 0. 1/4 to 0 is 1, times 2 is 2. Then we'll plug in 1. 1/4 to the 1 is 1/4, times 2 is 1/2. We'll do one more. 2. 1/4 squared is 1/4 times 1/4 is 1/16. Times 2 is, let's see, 1/8. Let's graph each of those points. So you get negative 1, 8. And again, I'm not graphing this to show you how to graph, but just to prove to you that the graph is going to decrease here like this. 0, 2, 1, 1/2, again, just using the points on this table right here, and then 2, 1/8. So let's see if I can do a better job of drawing this here. A little better, not perfect. So we have that exponential function decreasing. So as x gets bigger, we're multiplying by 1/4 more times, which will make y smaller. Thus, we are decaying exponentially. That's it, peeps. So you should be able to look at an exponential function, a graph, and see that if you have a b value that is less than 1 but more than 0, you will have a graph that looks something like this, provided that a is positive. And if you have a b value that is more than 1, a is positive, we'll have a graph that goes up. Little challenge, what happens if a is negative with any of these? Well, if a is negative, we've seen this with our reflections of graphs, right? If you saw that with absolute value graphs we took a look at there, you can check those out in an earlier chapter. We would flip everything about the x-axis. So you'd still be getting bigger and bigger numbers, just more negative here. So again, growing, but in the negative direction when b is more than 1. And here you would be, well, still getting smaller and smaller numbers, but they'd be smaller and smaller negative numbers, right? Flipped about the x-axis. Again, that's if a is less than 0. But again, smaller and smaller y values, just less negative. That's it, peeps. Know those b values. Understand the bigger this b value, the steeper that curve's going to rise when it's more than 1. The smaller it is, the more you're going to decay. See you next time.